Hey everyone, we are from Group H for ZAT 283 and we are going to present on our project called Clap Switch. So first and foremost, let me introduce myself. My name is Kavina Cynthia Louis with the matrix number of 144770 and my partner's name is Ahadiah Binti Mohd Jailani with the matrix number of 14406. Have you ever thought, how does elderly people or mobility impaired people such as wheelchair bound handle their electronic appliances at home? Especially the ones that requires them to move from their current location, just like switching on or off a switch. It becomes even more complicated when there is no one to help them to turn on or off their electronic appliances at home. This is where our clap switch helps them. As a solution, we have created a clap switch using a 555 timer IC. Our objective is to build a low-cost and reliable clap switch circuit that can be activated from any location just by clapping hands. Yes, it's that easy just by clapping hands.
Next, the components that we use are breadboard, 9-volt battery and battery clip, jumper wire male to male, capacitor, transistor, resistor, microphone, 555 timer IC, and red LED.
Next, we would like to show you how our clap switch works when a clap is detected. So, our clap switch is a device that can be turned on or off by the sound of a clap. This device can be basically described as a low-frequency sound pulse activated switch that is free from false triggering. The input component is a transducer that receives clap sound as an input and converts it to an electrical pulse. Generally, this device can be used in any other electrical appliances like light, fan, or television. For this project, we created the clap switch using a 555 timer IC to light up the LED once a clap is detected. To start off with, we have connected a dummy load resistor in the collector junction of BC547 to keep the collector junction of NPN transistor in reverse bias. It is also required by the transistor to amplify the input signal. The value of your dummy load actually depends on your supply voltage, and for our circuit, we have used a 9-volt power supply and thus we used a 100K resistor. If your LED stays on after you have connected the power supply, just keep increasing your value of your dummy load. We have also connected a 3.3K resistor in the base of T1 and the collector junction of T1 is connected with the base of T2. The anode of the condenser microphone is connected with the emitter junction of your T1. We have also built a monostable circuit using a 555 timer IC and then coupled the trigger pin with the output of the primary circuit. We have also placed a 22 microfarad capacitor in the pin 6 so the LED stays on for 2.5 seconds when the clap is detected. The value of your capacitor decides how long your LEDs should stay on when a clap is detected. We have also used a 100 nanofarad capacitor and coupled the output of your second transistor with the trigger pin of 555 timer IC. The 100 nanofarad capacitor is also important as it will filter out the continuous loud sound and avoid triggering the monostable circuit. When we have connected the power supply, the condenser microphone detects our clap and the LED stays on for 2.5 seconds. And even we blow, the LED stays on.
Now, I'm going to tell you about the problem that we faced during conducting this project and the solution. The first problem is LED stay on after the power supply was connected, and the solution is we increase the value of the resistor with 100 kilo ohm resistor. The second problem is wrong connection at the circuit. The solution is we refer to reference and online resource for a guideline. The last problem that we face is LEDs were not working after connected to the circuit, And the solution is we buy new LED and test it with a resistor and a battery. For the conclusion, our clock switch can function as expected and work efficiently. That's all from us. Thank you.